Hi, mathletes. Today we're going to be uncovering quadratics with number walls, and we're going to be using patterns and differences to discover quadratic equations. So again, today's video, we're going to explore how patterns and number walls can help us identify and understand quadratic relationships. You'll build number walls using addition and subtraction and learn how to find the differences to uncover hidden formulas. Then we'll connect these patterns to the structure of quadratic equations, the same ones that you've been seeing in algebra. So are you ready to get curious about how numbers grow? Well, first of all, what is a number wall? So here we have 3 bricks with a number inside each one. A number wall is built by putting more bricks on top to form kind of like a pyramid. And here's what one would look like. Then those bricks on top, those new bricks, we find those numbers by adding the bricks below. So for example, the 3 and 7 add to 10, the sum of 7 and 9 to 16, and the sum of 10 and 16 to 26. So if you haven't watched my previous video on number walls, I suggest that you watch it first because it's on linear expressions, and then this one in quadratics, which is a little more difficult, will make more sense. So here's a number wall that I've created. And what do you notice about how the numbers change across the bottom row? Here's something I saw. I noticed that they're growing faster as you move from left to right. In other words, they're not increasing by the same number, but they're increasing really quickly. And I also noticed that they were perfect squares: 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. So what happens when you move up this number wall, like this? Well, I noticed as you were moving up, the numbers started again to get larger a lot faster, just like moving from left to right. And I also noticed that they were not increasing by the same amount. In other words, they weren't all increasing by 4 or they weren't all increasing by 13. So what I did is I created 2 additional number walls, but this time instead of adding, I used subtraction. So I said 4 minus 1 is 3 and 9 minus 4 is 5, etc. And I did the same thing with the other 2. So what do you see, think, or wonder? You might want to pause the video here. All right, so if you continued with the pattern, what do you think the next number would be in your bottom row? Well, in this one, I know that these were perfect squares. So if this is 5 squared, that's probably 6 squared or 36. But this one, I don't know what this pattern is quite yet. So what I do notice is that I can find the next number by finding the differences of the rows above. So if I look at those 3 rows and I look at the third row, I notice that the third row has all 2's in it. So I'm going to put a 2 at the end. Then for this row, I notice that if I take my 2 and my 9 and I add them together, I should be able to get this number right here. So 2 plus the 9 should be the 11, and 2 plus the 11 should be the 13. Sure enough, because I know that the difference between 11 and 9 is 2, and the difference between 13 and 11 is also 2. And using that same reasoning, I can say, what can I subtract from 25 from? And then I get 11. So in other words, 11 plus 25, and then 13 plus the 24. Because the difference of 36 and 25 is 11, and the difference of 47 and 34 is 13. So let's see if we can write a formula for a number wall. So I'm going to use that first one that was my perfect squares. And we can start by writing a formula for the numbers by using the bottom row. So the general form of a quadratic equation is y equals ax squared plus bx plus c. So step 1 is to find differences, like we were doing before. So we subtract each number in the bottom row from the one to the left of it. So 4 minus 1 is 3, 9 minus 4 is 5, 16 minus 9 is 7, 25 minus 16 is 9. So now I have my second row. The differences in row 2 are 3, 5, 7, and 9. Now for step 2, let's find the second differences, or in other words, row 3. So we subtract each number in the second row from the one to the left of it. So 5 minus 3 is 2. And 7 minus 5 is 2. 9 minus 7 is 2. And you'll notice that they're all 2's. So the second differences, in other words, row 3, are 2, 2, and 2. And since the second differences are constant, in other words, they're all the same number or 2, it confirms that we have a quadratic pattern. So for step 3, we're going to find the value of a in our quadratic equation. So that's right here, that number that is going to be in front of my x squared. And in order to do that, we use the second differences, so the row 3. And we divide a by 2. So that second difference is we divide by 2. So 2 divided by 2 is 1. So a equals 1. Now we're going to solve for b and c. So we know that this is our bottom row, and I'm going to say x is the position. This is the first position, the second position, third, fourth, and fifth. And y is going to be the actual number. So in the first position, I have 1. In the second position, I have 4. The third position is 9. The fourth position is 16. And the fifth position is 25. So now we're going to solve for b and c using known values from the bottom row. Now we already know that the formula is y equals ax squared plus bx plus c. And we also know that a is 1, so I replaced the a with 1. So now let's use the first value, so value number 1. Here is my formula, and since it's the first value, I can replace the x with 1. And since the value is also 1, I can replace the y with 1. And now all I need to do is simplify. And when I simplify, I end up with 0 equals b plus c, because 1 plus b plus c, if I subtract 1 from each side, I end up with 0. Now we're going to use it with the second equation, and we're going to use the second value, which is 4. Since it's in the second place, x is 2. It's the second position, and the value is 4. And I replace them. So 4 equals 1 plus 2 squared plus b multiplied by 2 plus c. So 4 equals 4 plus 2b plus c. I subtract 4 from each side and I get 0 equals 2b plus c. Now we can solve by using systems of equations. So I take my first equation that I had, so b plus c equals 0, and my second equation, 2b plus c equals 0. And I subtract the first equation from the second equation. So I'm going to write my 2b plus c there, minus my b plus c. Then I put in my equal sign, and this first one equaled 0, so I put in 0, minus, and the second one is 0. So what I can say is 2b minus b is b, c minus c is 0, and 0 minus 0 is 0. So b equals 0. Now to find c, I replace b with 0. So here I have my 2b plus c equals 0. I replace the b with a 0. And 2 multiplied by 0 is 0, so c equals 0. Just to make sure that I didn't make an error, let's check it with the first equation as well. B plus c equals 0. B is 0, so c equals 0. So therefore c equals 0. So step 6 is to write the final formula. Well, we know that a is 1, we know b is 0, and c is 0. So now we can replace those variables with these numbers. So the quadratic formula for our number wall is a equals ax squared plus bx plus c. And we can replace the a with the 1, the b with the 0, and the c with the 0. And now we simplify it to y equals x squared, because the 1 is given. We don't need to actually put it in front of it. And we have our zeros, which are 0, so we can just say y equals x squared. And that is our formula. So let's verify it. Again, x is the position in the bottom row, and y is the actual number in the box in the bottom row. So y equals x squared. For the first one, we would replace the x with 1, and 1 squared equals 1. Oh, sure enough, it does. There it is. Let's try the second one. For 2, we would say 2 squared, and that does equal 4. For 3, 3 squared does equal 9. For the fourth position, 4 squared does equal 16. And for the fifth position, 5 squared does equal 25. So the conclusion, The quadratic formula for the bottom row 1, 4, 9, 16, and 25 is y equals x squared. Wow, that was a lot of steps, but it was pretty easy once we knew how to go through them step by step. Okay, let's write another one. This one's not as easy because we notice that it's not perfect squares, but here are our numbers 2, 7, 14, 23, and 34. Okay, again, we're going to use the y equals ax squared plus bx plus c. So we're going to find the first differences. And again, we're going to be subtracting. So 7 minus 2 is 5. 14 minus 7 is 7. 23 minus 14 is 9. And 34 minus 23 is 11. Okay, that looks good. So we know the differences in row 2 are 5, 7, 9, and 11. Now we're going to do the second differences. In other words, row 3. And 7 minus 5 is 2. 9 minus 7 is 2. And 11 minus 9 is also 2. And since they're all the same, 2, 2, and 2, we know that they're constants, which confirms that this pattern is a quadratic. Step 3, we're going to find the value of a. Again, we're going to be looking at row 3. And remember, a is that coefficient in front of the x squared. So that since it's a 2, we always divide row 3 by 2. So 2 divided by 2 is 1. So just like in the other one, a is 1. So the coefficient is 1. Now we're going to use our values to figure out b and c. So again, x is the position in the bottom row and y is the actual number. So we're going to solve for b and c using these values in the bottom row. Okay, so we already have our formula. And again, we're going to replace the a with 1. So here it is. Okay, so let's use equation 1 to find the first value of the bottom row. So here we have, again, x is 1 because it's our first value. And the actual, or first place, the actual value is 2. So here we go. We're going to replace our y with 2 because that's the actual value in the square. And x with 1 because it's the first position. And we simplify it and we end up with 1 equals b plus c. Now let's try it with the second number. So in this one, this is the second position. So x is 2 and the number is 7. So y is 7. Again, we replace the variables, simplify, and I end up with 3 equals 2b plus c. Now we're going to solve our systems of equations. So equation 1 is b plus c equals 1. And equation 2 was 2b plus c equals 3. All right, again, I'm going to write equation 2 first. So I'm going to write 2b plus c minus b plus c equals the 3 minus the 1. And now we'll simplify it. So 2b minus b is b, c minus c is 0, and 3 minus 1 is 2. So b equals 2. We replace b with 2 in each one of our equations. So the first equation is 2b plus c equals 3. So 2 minus 2 multiplied by 2 is 4. We subtract 4 from each side, and c is negative 1. Let's just double check it with equation 1. b plus c equals 1. Replace b with 2. Subtract 2, and c equals negative 1. So it confirms that c is negative 1. So now we can write our final formula. A is 1, b is 2, and c is negative 1. So the quadratic formula for our number wall is y equals ax squared plus bx plus c. And all we're doing now is replacing the variables with numbers. So there we go, replacing it. And again, as a reminder, we don't need to have that 1 in front of the x squared. So we can say y equals x squared plus 2x minus 1. So let's verify that. Again, x is the position in the bottom row and y is the actual number in the box in the bottom row. And there's our equation that we created. And let's check it for number 1. So for the first one, it should be 2 and it verifies. For the second one, it should be 7. Yep, the second one verifies to 7. For the third position, it should be 14 and it is 14. For the fourth position, it should be 23 and it works out to 23. And for the fifth one, it should be 34 and it does. So in conclusion, we can say that the quadratic formula for the bottom row 2, 7, 14, 23, 34 is y equals x squared plus 2x minus 1. Whew, let's try one more. Okay, last one. Again, we're going to do it the same way. Here's our general form for a quadratic equation. This time I have 3, 12, 25, 42, and 63. Again, we're going to find our differences, and I end up with 9, 13, 17, and 21. Now for the second row, the difference is 4, 4, 4. Oh, this time it's 4 instead of 2. That's interesting. All right. But since they're all the same number, it confirms it's a quadratic. Okay, now we're going to find A. And again, we use that third row. So it's going to be 4 divided by 2. So this times A is 2 instead of 1. Okay, we're going to solve for B and C the same way. Again, X is the position and Y is the actual number. And so here is our formula, but now I replaced A with 2. And let's use equation 1 as 3. So it's the first position, so X is 1 and the actual number, which is Y is 3. Replace it, and I end up with 1 equals B plus C. Now let's do it for the second one. So the second one is going to be the number 12. So second position, X is 2, and the value Y is 12. And I end up with 4 equals 2B plus C. Now we can solve using the system of equations, equation 1, equation 2. Subtract equation 1 from equation 2. Equation 2 is 2B plus C minus B plus C equals 4 minus 1. And I end up with B equals 3. 4 minus 1 is 3. Now I can replace B with 3. Let's use equation 1. B plus C equals 1. So I subtract 3 from each side and C equals negative 2. We'll just double check it using equation 2. And again, replacing B with 3. And I end up with 6 plus C equals 4. Subtract 6 and C equals negative 2 again. So it looks like we verified that C does indeed equal negative 2. Now we can write our formula. A equals 2, B equals 3, and C equals negative 2. And now we're going to take our quadratic formula. We'll replace the variables with the numbers, and I end up with Y equals 2x squared plus 3x minus 2. And lastly, we need to verify our formula. So let's check it for our position being X and the actual number being Y. And then we'll start with 3. So there's our equation. When X is 1, 3 should be Y, and it checks out. When X is 2, Y should be 12, and it checks out. When X is 3, Y should be 25. Yep. When X is 4, Y should be 42, and that checks out. And lastly, when X is 5, Y should be 63, and that checks out too. So in conclusion, the quadratic formula for the bottom row 3, 12, 25, 42, and 63 is Y equals 2x squared plus 3x minus 2. So there we go. There is our formula. Y equals ax squared plus bx plus c. And remember, the first step is to find the differences. The second is to find the second differences. Step 3, find the value of a. Step 4, use known values to solve for b and c. Step 5, solve the system of equations. Step 6, you're writing your final formula. And lastly, you're verifying that formula. So now you can create your own bottom row where all the numbers follow a quadratic pattern. But don't start with 1. Start with a different one like 2 or 3 or 4 or even 5. And then you can write your own formula. So what did we discover today? Well, we discovered that number walls are a powerful way to visualize number patterns. They help to see patterns grow in a special way, not just by the same amount, but by an increasing amount. That the second difference showed us we were working with a quadratic pattern. And we use those patterns to write formulas like y equals ax squared plus bx plus c and verify that they match the number wall. Quadratics aren't just about solving. They're about seeing how patterns grow and change. If you liked this video, please click the like button, and I'd love it if you subscribed as well. But as always, thank you for watching.